now we're into aluminium fixing design to AS NZS 1664. And we'll start with bolts and rivets because the code puts them together. As before, we pick out our strength reduction factors and our nominal fastener diameter. In this case, it's a rivet. The alloy is quite important. Just saying your material is aluminium is not enough. Aluminium comes in hundreds of different grades and tempers. So in this case, we're using a 6060T5. This is not a particularly strong aluminium alloy, but it's a very common one and often used in trimmings and angles and so forth. So we start again with a check on the minimum edge distance and minimum spacing. Because it's aluminium, there's at least 4 ways of doing almost everything. And so we check the bearing capacity, comparing it to the yield strength and the ultimate strength, and then taking the minimum for both of the sheets. We then move on to bearing on the flat surfaces and the pins on bolts in slotted holes, for example. Now, again, we've got 4 ways of doing it, 2 for each sheet, 2 for comparing yield strength versus the ultimate strength, and then we take the minimum, which gives us our capacity in bearing. We've listed the tensile and shear strength of rivets here, just for reference. And then we look at the tension loads in our connection. And that gives you a minimum tensile capacity of 2.83 in this case. We also look at factored shear loads, which is very similar. Look at our shear area and multiply by your shear strength to give us a shear capacity of 1.63. Now we move on to screws, in this case self-tapping screws. They're usually often self-drilling, self-tapping screws. We'll look at a small screw in this case, the same sort of diameter, it's 4.88. And we have our strength reduction factors taken from clause 5.3.2 of the code 1664. And so we compare our yield and our ultimate tensile strengths, and that gives us our design shear strengths. We take the minimum of all the 4 values. That's looking at tension. Again, we're looking at a pull out and a pull over. So just to remind you, it's not usually the screw, the bolt or the rivet that fails, but the material that you're joining. And in that, when the fixing is in tension, it will either pull out of the underlying material or pull over the fixing from the top material. So in this case, we have a pull out force of up to 2.52 and a pull over of 1.48 using the equations from the code. And the design tension capacity is simply the minimum of those 2 values, and we apply a strength reduction factor to it. So leave a like and leave a comment and subscribe to the channel. I see from the analytics that my second biggest audience is in Hong Kong. So welcome if you're watching in Hong Kong. If you have any comments, just put in the comment section under the YouTube video as well.